Hello, 6th grade. Welcome back to another YouTube video. So this lesson is supposed to be a refresher from class on how to do decimal multiplication. So we're going to talk through the process that we use in class to discuss how are we multiplying decimals and why are we doing it this way. So let's go ahead and get started. So I'm going to use a simple example. We're going to do 10 times 0.1. So, I'm going to write out the names for both of these numbers. 10 is just 10, right? 10 wholes. And 0.1, well, the first place after the decimal is called the tenths place. And I have one of them, so this is 1 tenth. Well, when I see the word tenth, I think about fractions. So I'm going to rewrite this as fraction multiplication to get an idea of what our answer might look like. So 10 as a fraction, again, is 10 wholes. So that's going to be 10 over 1 times 1/10. Well, 1/10 is going to look exactly like this. 1 in the numerator and 10 in the denominator. So doing fraction multiplication, this is pretty easy. We just have 10 times 1 on the numerator. And 1 times 10 on the denominator. 10 times 1 is simply just 10. And 1 times 10 is simply 10 as well. So our answer is 10 over 10. 10 tenths. Think to yourself for a second, what is 10 tenths? Well, this is one whole. Ten tenths makes a whole. So the answer we're looking for is 1. So we are going to do some decimal multiplication now. So we're going to line up our numbers. 10. The decimal would normally be here, right? 10.0. Because you can always add a 0 after the decimal. 10 wholes and nothing else, right? You just don't need to write it. Times 0.1. So I'm going to multiply. 1 times 0 is going to be 0. 1 times 0 is going to be 0. And 1 times 1 is going to be 1. And then we bring our decimal straight down, right? And we get 10. Wait a second. If 10 times 0.1 is 10, then what's 10 times 1? Excuse me for 1 second. So, we know that 10 times 1 is 10. 1/10 makes 10. Does it make any sense for 10 times 1/10 to make 10? No, we already did the fraction version of it and got that it's supposed to be 1. So clearly, there's something wrong with what we're doing here. So when you think, oh, we're working with decimals, I got to line up my decimals, think again. This only works for addition and subtraction. So our new question is, how do we multiply these in that case if we're supposed to get 1? Well, we're going to go back to our fractions. So 10 wholes times 1/10 ends up giving us 10 tenths, which we said was just 1 whole. But there's another thing we can think about. What happens when we divide numbers by 10? So if we say, let's say we have 70 divided by 10. Well, 7 tens go into 70, so this is 7. What if we have 60 divided by 10? Well, that's going to be 6. 6 tens go into 60. And then what about numbers like 65? What happens when we divide those by 10? Well, I'm going to convince you. 65 goes in between 60 and 70, right? 60 is 5 above 60, or sorry, 65 is 5 above 60 and 5 below 70. That's halfway between the two. So our answer's got to be halfway between the two of these. Or if I'm thinking about decimals, our answer is going to be 6.5. So when we divide by 10, that's like the same number, right? 65 and 6.5, that's the same number, but what's different? We have a decimal in the middle now, right? So if we have 65, we can also represent this as 65.0, right? Because you have 65 wholes and nothing else. So the decimal goes after the 65. I'm going to leave it be for now. And just know that the decimal goes after our 65. We know when we divide by 10, we have 6.5. So what's the difference? The only difference is our decimal now is in the middle of our number. So when we divide by 10, our decimal place moves 1 to the left. So when our decimal place moves one to the left, so decimal one place left. Excuse me, one place left when we divide by 10. Now, why is this? When we count to 10, right? That's why we work in what we call a base 10 system. So you go 1, 2, 3, 4, 5. 1, 2, 3. I'm going to do this on a new page, actually. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we get to 10, right? When we get to 10, we suddenly go from having 1 digit to 2 digits, excuse me. So the reason that when we multiply or divide by 10, we can just move our decimal, right? So like 7.1 times 10, you'll find out 7.1 times 10 is just 71, just like 7 times 10 is 70. When we multiply or divide by 10, that's like saying, oh, we're making 10 groups or splitting up into 10 groups. Well, when we have 10 groups, we have 10 digits. So we just move on to our next digit. We have to add another digit to talk about it. If this isn't making any sense to you, don't worry about it. All you have to know is the process. When we divide by 10, our decimal moves. So coming back here, we have 10 over 10. Remember, fractions is the same thing as division. So 10 divided by 10, the decimal is like here, so we just move it over. Why is this important? Well, we're going to get back to our problem. We have 10 times 0.1. Why didn't I line up the decimal? Our decimal would be here, right? Why didn't I line up the decimal? Because it doesn't work. It doesn't work when we line up the decimal. We don't line up the decimal and drop it down. Well, I'll give you a little piece of insider information. It actually does work when we line up the decimal. We have to do something special. So I'm not lining up my decimals. And this is the same thing as 10 times 1/10, right? Which is like dividing by 10. It's the same thing as 10 divided by 10. So our answer we know is going to be 1. But we also want to use normal multiplication just like we always do. So what I'm going to do is multiply this out, pretending I don't have any decimals in my problem. I'm just going to erase them, actually. So we can pretend there's nothing there. So 1 times 0 gives us 0. Excuse me. 1 times 0 gives us 0. 1 times 1 gives us 1. 0 times 0 gives 0. Oh, we have to add the 0 first when we move to our tens place. 0 times 0 is 0. And then 0 times 1 is 0. Add these up. And we just get 10. Right? So I'm just going to erase all these zeros at the bottom because we don't really need them. Adding zeros doesn't do anything to our equation or our expression. So when we multiply 10 by 1, we get 10. So my question is, what happened? How do we get our decimal back in the problem? Because we have 0.1. The key is, this is 1/10. So we have one number after a decimal place. This 1 is after a decimal place. Any number that's after a decimal place is telling us we only have a fraction of a whole. We have 1/10, right? So what I'm going to do to get our answer, we know our answer needs to be 1. Well, I just told you about when we count to 10, we have to move decimal places. So when you divide by 10, remember multiplying by 1/10 is the same as dividing by 10 over here. That means I'm going to move my decimal point over this direction. Left 1 place. Now we have 1.0. You may be really confused right now, but I'm going to show you it works out for all numbers. So what if I have 0.2 times 0.3? Well, I'm going to do this like normal. 3 times 2 is 6. And 3 times 0 is 0. So we just have 6, the number 6. If I had the number 6, my decimal would go after it because it's 6 wholes and nothing else. And this time, we have 2 numbers after our decimal points. There's 1, and there's 2. Remember, this is 2 numbers after a decimal point, so we're going to have to, this is like dividing by 10 twice this time, and I'll show you why with fractions. So this time we're going to move our decimal place over here, and our answer is going to be 0.06, which is the same thing as 6 hundredths. Remember, the second place after your decimal is 6 hundredths. Well, turning these into fractions, we have 2 tenths. Let me use a different color so this stands out, actually. So we have 2 tenths times 3 tenths. Doing our fraction multiplication out, our numerator is 2 times 3, which is 6. And we have 10 times 10 on our denominator, which is 100. Well, how would you read this fraction? 6 100ths. 6 hundredths. 6 hundredths. They match up. Our answer has to be right. If it works both ways, you know that your answer's right. I'm going to try one more example to show it doesn't matter if we're lining our numbers up. So this time I'm going to have 0.7 times 0.05. Our decimals aren't lined up, right? So I'm going to do it out, see what happens. We have 5 times 7 is going to be 35. Carry the 3. 5 times 0 is 0. Add that 3, you just have 3 here. The rest of our numbers are zeros, so it doesn't really matter. Our decimal would be here. This time we have 1, 2, and 3 digits after our decimal. So I'm going to move my decimal 1, 2, and 3 places. Remember, if you don't have anything in front, you can move it a place and add a 0 in front. So now my decimal's here, and I have 0.035. Well, this is the tenths, hundredths, and this is the thousandths place. Right? So this is 35 thousandths. And then I'm going to prove it using fractions. So 0.7 is 7 tenths. And we're multiplying that by 5 hundredths, right? 5 100ths. 7 times 5 is just 35. And 10 times 100 is 1,000. So again, our answers match up. 35 thousandths is the same thing as 35 over 1,000. If you're really confused right now, please ask me questions either in the comments or in class. I know this is a long video and very, very complicated, but the important thing is when you're multiplying decimals, you can do it like normal. So just to summarize, when multiplying decimals, all you have to do, line your numbers up. Or you don't even have to line your numbers up. You just have to make sure you're multiplying the correct numbers, and then multiply as normal, or multiply as if there's no decimal. Excuse me, my pen is having trouble today. 1. Multiply as normal. Multiply as if there is no decimal. Two, count how many numbers you have after decimal places. Or how many digits are after decimals. So as a reminder, 0.2 times, sorry, let me line this up better, times 0.03. In this case, 0.03. In this case, you'd have one digit after the decimal on your top number, and 2 digits on your bottom number. So this is a total of 3 digits after the decimal, or after decimals. And then step 3, move your decimal move your decimal That many places left. Hope this video is useful, and I will see you tomorrow in class.